As we look at the problem today, we're going to be looking at an application of our linear inequalities, where we're going to be able to graph the solution set on the Cartesian plane. So Tracy is selling purses and shoes to make some money for a trip. The purses cost $15 and the shoes cost $12. She needs to make at least $300 to go on her trip. We're going to write a function to represent the scenario and to find what the possible solution set would, or to at least represent the possible solution set. So let's take a look at what we have. We have $15 for every purse, and we have $12 for every set of shoes. If we wanted to, we could replace this P and S with our variables and say, if I'm going to have to multiply or find out how many purses I'm going to need, that would just be replaced by a variable, the quantity of purses that she sells. Plus, because we know that she's going to be selling shoes and purses, so that's an addition, I'm going to have some number of shoes. So in this case, I'm going to be using x and y to help me to see the relationship as it contains the Cartesian plane, so our y-intercept and our x-intercept. Now, it's related to this value 300. It says she has to make at least $300 to go on this trip. Well, if she makes more than $300, she can go on the trip. But if she makes less than $300, she can't. If she makes $300 exactly, as it says, then she can go on the trip, but just barely. So we're going to write this as greater than or equal to, because if she goes greater than the amount that she needs, she'll be able to go. And if she equals the amount that she needs, she still gets to go. At this point, you can see that this is in the standard form. If I'm going to write a function, which I already have, and graph it, I'm either going to have to graph it using the standard form, which I have right here, or I could convert it to the the slope-intercept form by moving everything other than the y back across that equality sign and solving for y. I'm going to show you this even though we don't need to do it. So I'm going to get the 15x by subtracting 15x on both sides. This, remember, keeps my inequality balanced. These then cross out, and I have 12y is greater than or equal to negative 15x plus 300. I still have the y attached to this 12, the coefficient. I don't want to know how many 12 shoes are going to be. I want to know how much one shoe, or how many specifically shoes are going to be my outcome to make this true for any amount of purses that I sell. So I need to divide by 12. So canceling these out, I then have y greater than or equal to. Now this negative 15x is also going to be divided by 12. I could reduce that to negative 5/4. So I'm going to be factoring out the 3x plus, and then instead of using this as just one divisor, I could separate it into the 15x as I have just done, and also the 300. So 300 divided by 12, which equals 25. And now I have my inequality. Let's take a look at what it looks like on the graph. I've set up my graph to where I'm dealing with, on the bottom, fourths across, so I have everything is in increments of 4, more or less, and so 2, 4, 6, 8, as you can see, 2, 4, 6, 8. But as I graph, it's going to be a lot easier for me to find the specific points if I have it in increments of 4, due to my slope being a down 4, right, down 5, right 4. So let's take a look at our actual inequality. So we have our intercept at 25. If I go down 5 over 4, my next point is going to be right here. So I put my next point in. Again, down 5 over 4. Put my next point right here. And I continue doing that until I have an actual line that goes all the way across. So for my purposes, I'm going to stop here, draw a line, more or less, that goes through the points that are true. I can have a solid line because I can equal that 300. If I couldn't equal that 300, if I had to have more than $300 just by 1 cent, I would have to use a dashed line like we've learned. So in this case, it says greater than. Typically, I would be going above and shading up in this region, greater than. But we have this area over here. This represents 0 for x. So over here, our x, we said, was related to the number of purses. So we could sell 0 purses, and then that tells us we'd have to then sell 25 shoes, or sets of shoes. I can't sell negative. It's not realistic. That doesn't fit for my scenario. So I have to sell something. So the area over here is actually not included. I can't sell negative amount. I'd be going in debt. I would owe someone. That would be like me buying something. And she's trying to sell to earn money. So in this case, what I'm going to want to do is shade everything to the right that tells me I'm incorporating only the positive values of the x. So in this case, over here. So I'm going to stop right here. I'm going to shade in anything in this area. Okay? And it's going to also be capped. We can't see it on this line, but the x-intercept continues out. I can't go negative y. I can't sell a negative amount of shoes either. And so when I get over there, if I were to extended this, I'm going to not be able to. Let's see if we can try that actually. So let's move this. Here we go. So if I were to extend this line, you'd see this line extending too. I wouldn't be able to go into that bottom area. So this area would also be off limits because I couldn't represent a negative cell. So I'm all contained into this area, and then it's going to just go flat. Anything up here or above contained in this small space. I'm going to change the color so you can see this with the orange. Anything that follows our line and is contained by positive values for both x and y would be my data set. So I'm going to have everything in here, and you can try it by actually plugging in some of those points and seeing how they make the original formula that we've written true.